Hello everyone, I am Dr. Naresh Kumar, Assistant Professor in the Department of Electrical and Electronics Engineering, Institute of Aeronautical Engineering, Hyderabad. Today we are going to have a discussion on the working principle of DC generator. So in this, before going to explain this working principle of DC generator, so first these are the terms I would like to explain. First, DC generator, DC motor and magnetic field, magnetic flux, conductor, right hand thumb rule, Fleming's left hand rule, and dynamically induced EMF. The very first definition in this DC generator. What do you mean by DC generator? DC generator is a device which converts from mechanical energy to the electrical energy, which converts from mechanical energy to the electrical energy. What about DC motor? DC motor is a device which converts from electrical energy to the mechanical energy. So the construction of DC generator and DC motor is same, but the working principles are different. Now next one is the magnet. What is meant by magnet? Magnet means which is having attracting property. So it is having two poles. First one is north pole and second one is the south pole. Next, which is having it attracts, it is having attracting property. Next, magnetic field. The region around the magnet is known as the magnetic field. This is the magnetic field. So this magnetic field can be represented with imaginary lines. That imaginary lines, the number of imaginary lines are known as the flux. So these flux lines always flows from north pole to the south pole. And these flux lines always flows from north pole to the south pole. Now this magnetic field can be represented with imaginary lines. The number of imaginary lines are known as flux. So flux is represented with phi, and this flux units are Webers. And next, this flux lines always flows from north pole to the south pole. So if strength of this magnetic second magnet south pole is greater than this first magnet north pole, then it flows from north pole to the south pole. Next, conductor. What do you mean by conductor? Conductor means the material. So here conductor means in which the active length of wire in the magnetic field, the active length of wire in the magnetic field in which EMF will be generated. So EMF will be generated in the conductor, and when it is placed in a magnetic field, according to the Faraday's law, d phi by dt is directly proportional to the d phi by dt. That material in the conductor only EMF will be generated. So that is conductor. This conductor allows the electricity to flow the material. Next, right hand thumb rule. So right hand thumb rule means, so hold the conductor. So see this, hold the conductor in your right hand like this. So first hold the conductor right hand. So this is the conductor. So this conductor current direction is like this. So thumb direction is the current direction, and this curled finger direction indicates the flux direction. This is the flux density. Flux means B equals to phi by A. So this curled finger direction indicates the flux, and this conductor, hold the conductor in your right hand. So this is the current direction, and this is this is right hand thumb rule. What about Fleming's left hand rule? Fleming's right hand rule. This Fleming's right hand rule can be used in the DC generator working principle to determine the current load induced EMF direction. Induced EMF, when you connect the load to the generator and current flows in the generator, and that current direction can be determined by Fleming's left hand rule. See this diagram. So here in your right hand, the right hand thumb rule. So first, so thumb finger, middle finger and forefingers are right angles to the each other. So here the thumb direction indicates the motion of the conductor, and this middle finger, this forefinger indicates the magnetic field. This is the motion of the conductor, and this is the magnetic field direction, flux direction, and this middle finger direction indicates the current direction. Motion of the conductor and magnetic field direction, that is from north pole to the south pole, and this is the current direction, induced EMF direction. This is right hand thumb rule. Three fingers, middle finger, forefinger and thumb fingers are right angles to the each other. So now here thumb indicates the motion of the conductor and flux indicates the forefinger indicates the flux and magnetic field, that is flows from north pole to the south pole, and this middle finger indicates the current direction. Next, induced EMF, dynamically induced EMF. Dynamically induced EMF means induced EMFs are two types: statically induced EMF and dynamically induced EMF. Dynamically induced EMF means conductor. So according to the Faraday's law, E is directly proportional to the d phi by dt. So to get the induced EMF, will be, so if there should be a rate of change of flux. Rate of change of flux can be obtained in two ways: either this magnetic field stationary or conductor is rotating, or conductor is stationary and magnetic field should be rotated. In case of DC generator, magnetic field is rotating and magnetic field is stationary and conductor is rotating. So in this way, d phi by dt, we can get that according to the Faraday's law, E is directly proportional to the d phi by dt, and so that induced EMF is known as the dynamically induced EMF. Dynamically induced EMF. Now here, if you connect the load, so here induced EMF will be developed, and if you connect the load, current flows in this. So current flows in the circuit. So this is the load. Current flows. So current, conventional current direction always opposite to the flow of electrons. So now here flux lines, this magnetic field is stationary and conductor is rotating. According to the Faraday's law, E is directly proportional to the d phi by dt, and induced EMF will be developed in the armature conductor. And if you connect the load to this conductor through the commutating system, and this brushes and current flows in this, and current flows. There is a closed path, there is a current. Now here, so first, the working principle. So the working principle of DC generator is Faraday's law of electromagnetic induction and dynamically induced EMF. So here, to explain these working principles, let us take one simple elementary model of DC generator. So first one is magnetic. In this model, so two poles, in between two opposite poles, one conductor is one single turn conductor is placed. So first here north pole is placed at left side, and south pole is placed at right side, and here conductor. So here flux lines always flows from north pole to the south pole. Here E is directly proportional to the d phi by dt. According to the Faraday's law, E is directly proportional to the d phi by dt. There must be rate of change of flux. So now how we will get a rate of change of flux? Either conductor, a single turn conductor should be rotated, or magnetic field, one should be rotated. Here I am taking magnetic field is stationary and conductor is rotating. Now here if you connect, so this is a and induced EMF will get, and if you connect the load and current flows in this, so this is the, so now here conductor is at horizontal position at this is, so conductor means single turn conductor, horizontal to the flux, this flux lines. So here phi equals to 0. So phi equals to 0. At phi equals to, this is the T and this is the EMF generated in the armature conductor. This is A, B, C, D. Here single turn conductor means two conductor forms a one turn. So here AB is one conductor and CD is conductor and two second conductor. Now here AB and CD are horizontal to the flux lines. So here phi equals to 0. Phi equals to 0 indicates. So here phi equals to 0 means flux lines always flows from north pole to the south pole, and if you place like this conductor, singleton conductor, so flux cutting is minimum, so almost 0. So small amount of flux cutting here, and so E is directly proportional to the d phi by dt, and flux cutting is a minimum, that means almost 0. So flux cutting is minimum means d phi by dt also minimum. And induced EMF is minimum, that is also almost 0 at 0 angle. So induced EMF is minimum value, and at 45 degrees angle. So first I will explain this one complete rotation in anti-clockwise. If I rotate this in a single turn conductor in anti-clockwise direction, so for complete one revolution, how much EMF will be generated, that I will explain. Now here at 0 degrees, now at 45 degrees, so at theta equals 45 degrees, this is 45 degrees, this is A and B, and this is C and this is D. Now here at this moment, here E is directly proportional to the d phi by dt, and flux cutting previously at phi equals to 0, theta equals to 0, and flux cutting is minimum. Now flux cutting is increasing. So previously at between north pole and south pole, so this singleton conductor horizontal. Now here rotate in anti-clockwise with 45 degrees. So now at this case flux cutting is increasing. So flux cutting is increasing means d phi by dt is increasing, and induced EMF is also increasing. So this is 0, and at 45 degrees case, so flux cutting is increasing EMF. This is the theta r time. Now here next case at 90 degrees case, theta 0 degrees case minimum, and that almost 0, and at 0 degrees and at 45 degrees theta equals to increases. So this is increases, and at theta equals 90 degrees this case. So at this case here, this is A and B, and this is C and D. So here it is at vertical position, so flux cutting is maximum at theta equals to 90 degrees. So at 90 degrees, so here it's 0 degrees case almost 0, and at 45 degrees, so increasing, and at 90 degrees increasing. It is also increases flux cutting, and induced EMF is maximum. So here flux cutting at this moment, so it is increasing, that is maximum, and d phi by dt also increasing, that is maximum, and E is directly proportional to the d phi by dt. This one is also maximum. At 0 degrees case 0, and at 45 degrees between this increases, and maximum value. Here maximum amount of EMF, maximum value. After 90 degrees, next 45 degrees anti-clockwise rotation. Now here at this is A and B, and this is C and D. Now at this condition, theta equals 0, and theta equals 45 over 0, 45, 90, and 135. So theta equals to 90, and theta equals to 135 degrees. So at this case 0 increases maximum, and at this case decreases. So in the middle, in the vertical position, so flux cutting is maximum. Now rotated in anti-clockwise with again 45 degrees, 135 degrees, this means so flux cutting is here is the maximum means here is the maximum flux cutting. So here at 135 degrees case, flux cutting decreases. So flux cutting decreases means flux cutting decreases, and so d phi by dt decreases, and E is directly proportional to the d phi by dt. Here is increasing maximum value, and here flux cutting decreases and induced EMF will be decreasing. And at 180 degrees case, so here this is A and B, and here this is C and this is D. This is C and this is D. Now here positions of the conductors are interchanged. The conductor AB conductor previously at right side comes to the left side, and the conductor CD conductor previously at left side comes to the right. The positions of the conductors have been interchanged. Now here this is almost same at theta equals to 180 degrees case. So at theta equals 180 degrees case, almost at 0 degrees condition stage. So at this case, flux cutting is minimum. Flux cutting is minimum, almost 0. So d phi by dt is 0. D phi by dt is 0. So he is directly proportional to the d phi by dt. So this is almost 0 minimum value. So 0, 45, 90 and 135 and 180. 0 increasing maximum, and decreasing 0 again 0. But here AB conductor and CD conductors only interchanged. So 0 and 180 degrees case. Now here at 225 plus 45, again anti-clockwise rotation of 45 degrees. So now here the conductor position, now here, so 225 degrees. So in this case it should be increases in reverse direction, that I will. So this is the C and this is D and this is A and B, and here theta equals 0, theta equals 45, theta equals 90, theta equals to 135, theta equals to 180, and theta equals to 225. So here flux cutting is 0, increasing maximum value, again decreasing, and here it should be increasing, but positions of the conductor. So this condition and this condition must be same. Here 0 and this one. This is 0 and this is at 45 degrees case, this is at 90 degrees case, and this is at 135 degrees case, and this is at 180 degrees case, and this is at 225 degrees. So here flux cutting is increasing. But here at 45 degrees AB here and CD is here. But here same situation, but conductor positions have been interchanged. Here is also flux cutting is increasing, and d phi by dt is increasing, and E is directly proportional to the d phi by dt, and so this is also increasing. So this is not decreasing, increasing in reverse direction. So increasing in reverse direction. So now at 2225 plus 45, that is 270 degrees. So this should be also increases, but that is, so here this is C and D, this is A and B. So theta equals 0, 9, 45, 90, 135, and next to 180, this is 225, next 270 degrees, increasing maximum value, and decreasing, this is increasing, and this is should be also increasing. So now this position, this 90 degrees position, and this, so here flux cutting is increasing, and that should be maximum, and d phi by dt is also increasing, that is maximum, and E is directly proportional to the d phi by dt. This is the increasing and maximum. So this is increasing from 225 to 270, max increasing, and maximum value in reverse direction, negative, and at theta equals to, so this case, this one and this one. So in the 90 degrees case, AB is here and CD is here, only conductor positions have been interchanged here. at 270 plus 45 after anticlockwise rotation of 45 degrees. 270 plus 45, 315, 0, 45, 90 and 135, 180. Next 210, sorry, 180, 215 and 270, 225, sorry, and 315. Now here this is C and this is C and D, this is A and B. Now here and in this case, so flux cutting is decreases, and d5 by dt is also decreases, but it is in reverse direction, and EMF is also decreases. So now here EMF is directly proportional to the d5. This is 180, and this is up to here we have seen in the last slide. So here this is decreasing direction, decreasing in reverse direction, not increasing. And now at normal position, this one here, this is now it is A, B, C, D at theta equals 0 position condition and theta equals to 90 degree. Same again, this is a again. So now one complete rotation of conductor, singleton conductor in anti-clockwise direction. Here we got one complete sine wave. So see here. So now when you connect the load and current flows in this circuit, and current flows in this circuit. Now the EMF waveform. So up to 2 pi. So up to 360. So this is 0, 45, this is 90, and this is 180, and this is a 270, and this one is a 315. This is 275. So this is EMF. So one complete revolution, once complete sine wave we will get for second rotation here. So now here in this way EMF will be generated. So rotating conductor is rotating in anti-clockwise, means that is mechanical energy, and here we got a EMF here in the conductors EMF, and that is electrical energy. So here in this way DC generator is generating electricity by using mechanical energy, and after getting mechanical energy, so that electrical energy is given to, if you give into the load through the commutator system and brushes, and current flows in the circuit. So now if you have any doubts in this lecture, you can comment in the comment section below. I will answer to your queries. Thank you very much to you.
Like, share and subscribe. Hit the bell icon for more updates.